Now let's continue with our questions on the derivative of inverse trigonometric functions. Now we shall be looking at this question first. Here we are to differentiate to find y prime of the function y is equal to 1 plus s squared, the tan inverse of x. We are to differentiate this. The first thing you need to note is that this is a product of two functions, this and this. Therefore, we have to apply the product rule. In applying the product rule, y prime is going to be equal to, the rule says that hold the first expression, which is 1 plus s squared. Then you differentiate this. Remember that the derivative of the derivative of the tan inverse, thus the inverse tan function, is given as 1 over 1 plus s squared. So we will get 1 over 1 plus s squared. So you hold this and differentiate this. Plus, you also hold the tan inverse of x. Then you differentiate the first one. When we differentiate the first one, we will get 2x. We are done. So all what you need to do is to simplify. Y prime should be equal to 1 plus s squared over 1 plus s squared. Or let me just do it straightforward. This will cancel this to get 1. Then plus 2x tan inverse of x. And that is the final answer. This one is very simple. Now let's move on to the next question. Find y prime if y is equal to e to the power sec inverse of t. Now here, it is appropriate to use the u substitution. So let's start by saying that let u be equal to sec inverse of t. Now you recall that in the given formulas, when you differentiate sec inverse of x, you get 1 over x root of s squared minus 1. So we are going to use this formula. So du dt, that is differentiating sec inverse of t, will give us 1 over t, then the square root of t squared minus 1. So that is how to differentiate the sec inverse of t. Now let's substitute u into the original function. Therefore, we will have y to be equal to the exponent e exponent sec inverse of t, and we know that sec inverse of t is u, so we have e to the power u. Now we can also differentiate y with respect to u, dy du. Here, this one is just an exponential function, so you get the same expression. Dy du is still e exponent u. Now, we have to apply the chain rule, which says that dy dt should be equal to dy du times du dt. So we have dy dt to be equal to dy du, and dy du is e to the power u times du dt, and du dt is 1 over t, the square root of t squared minus 1. Then finally we can write dy dt to be equal to e to the power u all over t root of t squared minus 1. But we know that u is equal to this. So wherever you see u, put sec inverse of t there. Therefore, dy dt is equal to e to the power sec inverse of t, then all over t root of t squared minus 1. And that is the final answer. Let's look at our last example. Now, in this example, we have y is equal to sine inverse of s squared plus 1. You can pause the video and try your hands on this. Now let's solve it. Y is equal to sine inverse of s squared plus 1. Here too, it is appropriate to apply the chain rule by first letting y, letting u be equal to s squared plus 1. Then we know that du dx is equal to 2x. Now we can substitute it back into the expression to get y is equal to sine inverse of u. Now we can differentiate dy du. Now this is the sine inverse of u, and we know that when you differentiate the inverse sine, you will get 1 over the square root of 1 minus u squared. Let these formulas be on your fingertips. Know them by heart, because you'll be using them in your exams. Now, we can apply the chain rule. We know that dy dx from the chain rule is equal to dy du times du dx. So let's substitute dy dx should be equal to dy du, and we know that dy du is 1 on the square root of 1 minus u squared, then times du dx, and du dx is 2x. So we have dy dx is equal to 2x all over the square root of 1 minus u squared. Then what is u? We know that u is s squared. U is s squared plus 1. So we have to do that substitution. Therefore, dy dx is equal to 2x all over the square root of 1 minus u squared. Remember that if u is this, you're going to have u squared to be 1 minus s squared plus 1 all squared. Then you can leave your answer here, or if you like, you can expand it and simplify. But I will leave it here. And that is the final answer. Alright. Thank you for watching.